Tatatatat, animal transport. Animal transport. Tayo talagang gumana. Okay, animal transport. Topics. Maraming topics. So, isa sa mga topics ay ang transport systems functionally connect the organs of exchange with the body cells. Body cells, ibig sabihin yung mga cells na will need nutrients, will need oxygen, will require yung pag-release ng waste material. So, ang responsible sa pagkuha nun, pag-connect ng mga cells na yun dun sa mga cells or mga organs or tissues na magre-release, let's say, ng waste or magpa-process ng waste or magbibigay ng nutrients ay yung transport systems. Same as your xylem and phloem, pero sa atin halos hindi na-differentiate yung for nutrients and water. Mostly it's for yung blood vessels na mismo. Pero syempre, we can argue the lymphatic system, siya yung mostly interstitial fluid. Most invertebrates have a gastrovascular cavity or a circulatory system for internal support. Kung titignan natin, kung susuriin natin mabuti yung sentence, it seems that halos karamihan ng invertebrates ay gumagamit ng gastrovascular cavity na it depends dun sa body plan of the organism. If the organism has a very thin body plan, it will use a gastrovascular cavity kasi this is a very primitive type of transport system wherein diffusion is the main transport system or transport mechanism, not only as yung taga-transport ng nutrients but dun sa specific tissues, but taga-transport all throughout the body. Okay. So vertebrate phylogeny reflected in adaptations of the cardiovascular system. So let's say yung sa mas evolved na organisms na yung may mas makakapal na body plan na. So sino ba mas magkakaroon na mas vascularized na vascular system? Okay, tama. So ang magkakaroon ng mas vascularized, mas branch na blood vessels yung mga taong may mas makapal na body plan, kasi kailangan pang ma-reach ng mga blood vessels yung mga malalayo na tissues na yon. So for example, so let's say compare natin to. So ito, let's say yung mga nutrients, these are cells. Okay, so yan, dalawang layer lang. Compare natin sa ganito na tissues. So dagdagan pa natin. Kapal-kapal niyan. So these are the nutrients. So nutrients and then nutrients. Okay. So most likely this one, baka manipis lang na blood vessel na ganyan. Okay. So about this one, yung nasa right, kaya ba ng ganitong blood vessels lang? So most likely kapag yan ang ginamit mo, hanggang dito lang yung diffusion yan. So anong gagawin mo as an organism? So iba branch mo yung blood vessels mo. Now, kung magdi-diffusion ka, possible na. Okay? All throughout. Okay? So, yun po yung explanation natin sa vertebrate phylogeny, yung in terms of advancement dun sa vascular system. Same sa ectotherm versus endotherm. Okay, so start tayo explain natin. Endo means yes, inside, while ecto, ibig sabihin niya ay yes, outside. So how about therm? Therm, ang ibig sabihin niya ay yun nga, temperature. So endotherm inside temperature. Ibig sabihin, yung organism, ginagawa niya yung temperature niya physiologically inside its body. While ectotherms, nagre-rely sila sa outside environment para makagawa ng or para ma-heat yung katawan nila. So, hindi po natin gagamitin yung term na cold-blooded versus warm-blooded. Bakit? Kasi misnomer siya. Kasi minsan, yung mga cold-blooded, mas mainit pa yung temperature nila kaysa sa mga warm-blooded. For example, yung mga animals na tinatawag nating cold-blooded, okay? Let's say, nasa desert sila. E di, kung sobrang init nung temperature sa desert, e di mas magiging sobrang init nung internal temperature nila. So, let's say, tinatawag kang warm-blooded, pero yung temperature mo, 27 degrees Celsius lang. E yung outside temperature dito is 33. Tatawagin pa ba natin cold-blooded yun? Okay? So, kung titignan natin dito, based on metabolism, ectotherm versus endotherm, sino kaya ang mas vascularized? Oo, tama. Yung endotherm. Kasi mas mataas yung metabolism na. They require more energy. So, mas marami dapat energy magamit. Mas matransfer yung oxygen. Mas matransfer yung nutrients. Okay? So, yun. Mali. Ayun. So, next. Double circulation in mammals depends on the anatomy and pumping cycle of the heart. So, pakita ko later on yung explanation ko dyan. So, structural differences of arteries, veins, and capillaries correlate with their different functions. For example, artery versus veins. So, artery again, away from the heart. Veins, back to the heart. So, ano bang major difference nila? Sino ang nagre-receive ng blood directly from the heart? Yes, correct. That's the artery. So, kung artery ang nakakakuha ng blood directly from the heart, sino ngayon na makaka-experience ng mataas na pressure or force? Siyempre, yung arteries. Okay, so, what can we expect dun sa structure ng artery? Can we expect ng makapal na muscle layer or manipis? Yes, we expect ang very thick muscle layer sa arteries. Imagine veins ang gagamitin mo doon. Isang pump lang ni heart, isang ganun lang, putok na si vein. Okay? Or hindi naman, let's say mga 4 naman. Yun, putok. Kung capillary, putok, heart attack si tatay. No? So, physical laws governing the movement of fluids through pipes affect blood flow and pressure. This will be discussed next quarter. Transfer of substances between the blood and the interstitial fluid across the thin walls of capillaries. This will be discussed next quarter. Components of blood next quarter. Okay? So, as what I was explaining kanina, gastrovascular cavity, presence of two-cell thick body wall, serves for digestion and circulation. Both layers are bathed by fluid. Inner layer only exposed to food. Okay? So dahil sa sobrang nipis niya, it will only need diffusion as its transport mechanism para ma-transport yung mga food na digest dun sa gastrovascular cavity. Okay lang na diffusion yung gamitin. Okay, so planarians and other flatworms also have gastrovascular system. Body shape ensures the efficient transfer of food. Sir. So tignan nyo to. Okay, imagine kung yung gastrovascular cavity niya ay ganito lang, pahaba lang, walang branching dun sa periphery. So it will not be enough, diffusion will not be enough. Bakit? Baka kasi yung mga tissue dito sa outermost part ng katawan, hindi na rin makaka-receive ng food or nutrients or makaka-release ng waste. So ang adaptation is to make branches. So, ano nangyari? Nag-branch out. Ngayon, na-reach na yung outermost layer or outermost part ng body. Just like yung example ko na dinrawing kanina. Dun sa yung thick body plan. thin body plan? Sino ba yung mas mag-gastrovascularize? Magbabascularize. So, nagpa-follow siya. Okay, next. Ayun. Open versus closed circulatory system. So, paano yan? Nag-evolve na. Hindi na kaya ng gastrovascular cavity. That's suitable for animals with many cell layers. Ayan, kumapal na kasi kung para makapag-colonize ka ng ibang terrain, let's say, ganun, kailangan mo mag-specialize. Ano bang kailangan para makapag-specialize ng mga body parts? Kailangan mo na mas maraming cells. Kung mas maraming cells, mas makapal na body plan. Again, sabi natin, kapag makapal yung body plan, hindi na enough in diffusion. So, what you need is a circulatory system, not a gastrovascular system, a circulatory system. So, open versus closed overcomes the limits of diffusion. Ang diffusion, mabagal, pero enough sa manipis na body plan. Ito, okay lang, kasi may nagpa-pump dun sa transporting fluid natin, dun sa circulatory fluid natin. Circulatory fluid, pwede pong hindi siya blood mismo, pero ito po ang mga requirement: circulatory fluid, tubes, pumping organ, or the heart. So, anong ginagawa ng heart? Anong ginagawa ng heart? It produces the blood pressure, motive force for fluid movement. Pag hindi na gumagana si heart, hindi na siya magpa-pump, wala nang magpupush sa blood, hindi na makapag-transport ng nutrients, hindi na makakuha ng waste para ma-release outside. Okay, so yun po yung main function nila. So, ito po yung di-discuss natin. So, bakit ganito yung itsura ng circulatory system natin? May dalawang circuit. Pero ito, isang circuit lang. Ito, dalawa. Pero you can see purplish dito. Dito, dalawa. Pero, yun, magkaiba. Blue and then red. Okay, let's start with open circulatory system. There's the presence of a heart. Ang special sa kanila, meron silang ostia. Hindi yan yung ostia sa Simba. Okay, so no distinction between blood and interstitial fluid. We will call it as the hemolymph. So, sinuses, just like yung sa sa may mukha, no? Interconnected spaces that surround organs. When the heart contracts in an open circulatory system, it pumps hemolymph. If it relaxes, it draws hemolymph through the ostia. Okay, so explain natin paano ba 'to nagwo-work. Okay, yun. Okay. So let's say this is the heart. Okay. This nangyari? What happened? Okay, whatever. What happened? Okay. Ito yung heart. So, gawin natin. Pagandahin naman natin yung heart. This is the heart. Okay. So, okay. This is the blood vessel. Ostia. Yan yung butas. Yun. Okay. Okay. The tube. Then, let's say there's a space here. That is the sinus. Arrange yung space. Okay. And then let's say there's an organ here. Okay. So kapag nagpump yung heart sa isang open circulatory system, pag nagpump yung heart, ang mangyayari is yung hemolymph or yung blood flow out. Okay. Together with the hemolymph. So ang mangyayari, i-release niya yung mga nutrients, dadali niya doon sa mga organ. Okay? And then when it relaxes, it will take away all the hemolymph. Lahat ng pwedeng makuha doon sa area na yon. So ano mangyayari? Ang possibility na to, Possibility dito, pwedeng hindi po ma-deliver lahat ng nutrients. Bakit? Bago po ma-deliver yung mga nutrients through diffusion is